2-2, differentiability. Alright, so differentiability refers to how well behaved a graph's slope is. Alright, so when you have a graph, you need to look at the slope and ask yourself, does this graph have a slope? And does the slope of this graph ever suddenly change? All right, for example, let's look at this graph. It's the graph of x equals 2. It's just simply a vertical line at x equals 2. What's the slope of this line? Well, the slope of the line is undefined. Why? Y'all should all be able to answer this question. Well, the rise, if we picked 1 and -1, so 0.21 and 2 -1, and plugged it into the slope equation, which is rise over run, it would give us 2 over 0. And if you remember from a few videos back, dividing a number divided by 0 is infinity. So you can either call this undefined or infinity. Alright, but it does technically have one. Alright, now let's look here. Let's look at x squared plus y squared equals 4. It's the equation of a circle with a radius of 2. What's the slope of the line right here? Well, if you draw your tangent line, it's a vertical line that is a terrible vertical line. But the slope at that point is either infinity, like our x equals 2 line, or does not exist. Alright? What about up here, at this point? Well, it runs this, that's a terrible tangent line again. It runs this way, and the slope here, the slope of a horizontal line, is simply 0. And then we get back to here, it just repeats this side, and down to here, it just repeats the top. Alright, so m equals infinity, or does not exist. And down here, you have your tangent line, m equals 0. Alright, so let's look at one more example, and then we'll go a little further into this. What about this? It's the graph of y equals the absolute value of x. Well, the slope of this side is simply -1, right? Because the absolute value graph, has a slope of 1 on the right side and -1 on the left side. But now, what about at 0.00? All right, that point right there will cause us grief with this graph being differentiable. All right, because this graph has no slope at x equals 0. All right, since it has no slope at x equals 0, this graph gives us grief and therefore is not differentiable. Now, if this had been y equals x squared instead, then it would have been fine, because the graph of y equals x squared is a parabola. And as you can see, the slope will smoothly change all the way around this. All right, so this would be okay. All right, so let's wrap some of this up a little bit. A graph is said to be differentiable if the slope exists everywhere and slopes always smoothly change. I guess I can't change that from slope to slope because I put an effect on it. All right, if the slope exists everywhere and slopes smoothly change, meaning no hooks, so you can't have any kind of gaps like this or anything, no points, and no sharp edges. All right, it has to smoothly change. Like this has no hooks, points, or sharp edges. Same with these two, no hooks, points, or sharp edges, no hooks, points, or sharp edges. All right, moving on. Continuity and differentiability. Continuity means that the graph is nice and smooth, not nice and smooth, with no jumps, gaps, or holes. If you remember back to the pencil rule, to be continuous, you have to be able to draw your graph without lifting your pencil. And differentiability means no sharp edges or hooks. So, if a graph is continuous, it may be differentiable. But to be differentiable, it has to be continuous. Okay, it has to be continuous to be differentiable. All right, let's look at a few examples now and make this make some more sense. Let's look at this function. F of x equals x squared for x is less than 1 and 2x minus 1 for x is greater than or equal to 1. Is f of x continuous and differentiable at x equals 1? Well, let's test continuity. First, you should know you just plug in x equals 1 into both equations. So for the top, we're going to have 1 squared, which equals 1. And for the bottom, we're going to have 2 times 1 minus 1, which is 1. So since these are the same, it is continuous. All right, so since it's continuous, it may be differentiable. So now let's go check on differentiability. The first thing we need to do is we need to find the slopes of these lines. All right, so we need to take f of x and find the slopes. All right, well, we went over slope in the last lesson. You know, it's f of x plus h minus f of x divided by h. I'm not going to do all that. I'm just going to write you down the answer. But the slope of x squared will be 2x for x is less than 1, and 2 for x is greater than or equal to 1. Now, what we need to do is now we need to plug in 1. Now plug in x equals 1, because that's the point that we want to know if it's differentiable at. So plug in x equals 1, and the top slope equals 2 times 1, which is 2, and the bottom slope equals 2. Since these are the same, it is differentiable. Check mark. All right, so our function f of x equals x squared for x is less than 1 and 2x minus 1 for x is greater than or equal to 1 is continuous and differentiable at 1. If you were to graph this, it would look like this. Here's x equals 1. You'd have your parabola coming from this way, looping down, but when you got to x equals 1, instead of continuing to be a parabola, it is a straight line. So there are no hooks or sharp points. So therefore, this graph is continuous and differentiable, or this function. All right. So remember, for continuity, you simply take the functions as is and plug in the point that you want to know if it's continuous at, in this case 1. You plug it in, make sure they equal the same thing, both the top and the bottom equation. For differentiability, you find the slopes. Okay, these are the slopes of the top equation and the slope of the bottom equation. You plug in the same x value that you did for continuity, and if you get the same value back out as well, it is differentiable. All right, so let's look, here's our last example. Let's look at f of x equals the absolute value of x. So negative x for x is less than 0, and x for x is greater than or equal to 0. First, let's test continuity. So we want to plug in x equals 0. So plug in x equals 0. So for the top, we get negative 0, which of course is just 0. And for the bottom, we get 0. So since they are the same, since the top is 0 and the bottom is 0, it is continuous. Now for differentiability, we need to get the slopes So the slopes for the top one is -1. The slope for the bottom one is 1. X is less than 0. X is greater than or equal to 0. So plug in 0, and since there's no x's, we can't really plug in 0. But if you notice, the top has a slope of -1. The bottom has a slope of +1. So therefore, these are not the same. So this is not differentiable. And if you remember, we actually did the absolute value equation at the beginning of this lesson, and it has a sharp point, which is what makes it not differentiable. It comes down and then bounces back up. So there we have a sharp point. So therefore, it is not differentiable. All right, even though it's continuous, because you can draw the whole graph. You think of the pencil rule, you can draw the entire graph without lifting your pencil. But since we have a sharp point at x equals 0, it is not differentiable. All right, see you tomorrow.